The other thing that that we need to do here is that center mass. The thing that you as designers need to consider is whether or not that's likely going to change. Okay, so right now we have 36 subdivisions. Okay, the way that I do it, if I know that these 36 subdivisions are probably going to stay at 36 subdivisions, is I can do a list item and grab specifically the 4 center elements and remove them from the list of surfaces that I'm going to do this operation on. That part's really simple. If it changes, you need to make a decision as to like how much you expect it to change. Like, looking ahead, is my professor probably going to say, you know, more or less subdivisions? That's probably not problematic. So I think that this is a reasonable way to move forward. So let's try that out. The key is you just need to find where the subdivisions are being created before they're extruded, and then you can remove them. So the way that I'll do it is I think the area I want to operate on is the original surface right here. So let me turn these off. Not quite that one. Okay, I'm going to go all the way back to these. So let's separate this all. Grab those. And for those of you who might not have seen that, I'm going all the way back to the beginning. That's this right here. So I have 36 of these. I need to find which are the 4 in the center and then remove them. The reason I'm doing it via list item rather than a subtraction is I don't really know how the subtraction would change the subdivision of the surface. That would be difficult to calibrate, getting the exact subdivision of those 4 elements. So anyway, let's do it this way. I'm going to go to set, list, and list item. And plug this in here. So we know that index item 0 is that one right there. Okay, I can plug a panel in here and do this manually. Now this is one time where I think doing it manually could be really helpful, actually, because you just drop a panel in and you can type in exactly the values you want. So what I do know is that those 4 values in the center are going to be in the 3rd row, which means it's at least 12. And they are the 2 in the middle of a set of 6, so it's going to be 12, 13, and 14. If you think of it this way, right? These are going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then 13 and 14, and then the next one is going to start with 15 and 16. Okay, I know that off the top of my head, but I can actually show you it here. 0 to 20. You plug that in, and you just start finding what value you want. So we go all the way up to 6. Well, 5 actually, and it goes through there, and then you go up to 11, that's that one, and then you go up a little bit further and you get to value 14, which is the 15th index, and that's it right there. So you want those 2, and then you want to go up again to 20 and 21. So I'm going to do 14, 15, 20, and 21. Plug those in here. See that? So that helps me select those 4 elements. Okay, that's one part of it. The other part of it is I want to actually reduce those and remove them from the list of surfaces that's being fed out here. Okay, so I can do that using call pattern. So let's go to set sequence call pattern. Actually, no, sorry. Let's do call nth. Okay, so this is call or remove every nth sorry. Call index. Sorry about that. Call index is going to remove specifically those indexed items in that list. Okay, so similar to subsurf, or similar to list item, we just plug the same value of indices in, and we plug that in there. And what we are left with is everything but those values. Okay, it's exactly the same thing. It's just with list item, we grabbed the elements in the middle, and with call index, we removed them.
So what happened to the extrusion in the middle?
The extrusion? Well, we haven't gotten there yet. So first things first, everyone. I need to replace the connections with just these elements. Okay, so I'm going to plug in. You might want to pause this here and lock your solver, depending on how complex your definition is. But you plug each one of these into those two and just replace that whole connection. Okay, so that way, when you look at this extrusion and this extrusion, it doesn't include that center.
So where are we going to put it?
You just replace the two connections that subsurf had before.
Oh.
You guys following so far?
Yeah.
All right, so now what do we do about that center column, right? That's the next step. Well, I can't really see in this example how far up it goes, but I do know it goes down and it meets the ground. So I just need to take this element right here and extrude it down. However, this example has it as one mass. So while I already subdivided the surface, I kind of need to bring it back together again and join it again. It sounds redundant, but it's really not, because we did that subdivision as an organizational function, and now we just want those ones to be rejoined. So I'm going to go to intersect, shape, and I think we can do it with solid union. Turn that off, and it looks like open brep, but it still shows the subdivisions. Oh, I think I know why. So this is a brep, but I think I need to do what's called a merge faces to get it to clean that up. And some of you more advanced Rhino users should know merge all faces, the command. So this is the same thing. So let's plug that in there and see if that did the trick. Yeah, there we go. One surface. Okay, and then it's as simple as, let's borrow this extrusion. Put that up there, we'll plug our brep into that, and then change that value to -50. Okay, so looking at this as a giant mass, I mean, proportionally it's pretty far off. I really don't have the same proportions as that, but that's the essence of the building. Then it's just a matter of changing your parameters and getting it to be sized right. What questions do you have? Is that a question or no? Okay. All right. So, yeah, that's it. I'm going to make sure you guys are caught up before we move on to the next one.